right, we are now moving into our fifth little video clip. I hope this is working well for you, and I really know that our time in class is going to be much more fruitful because of this early discussion here. Now, I had asked you to work the question or example 2-6 so that you could give this a try. So now let me work through the answers with you to see how you're doing and see if I can clarify or fix any problems. Now, this first number, we're assuming these are not exact, that these are all measurements in this case. Now, 250 absent decimal, remember you start from the Atlantic side, start counting at your first non-zero, that would have 2. Present decimal, start counting from the Pacific, 1, 2, 3, that 0 counts as a measurement. It's not holding magnitude. Present decimal, start from the left. Don't start counting. Those zeros are magnitude. First non-zero, you start. 2 for that number. Absent decimal, this poor little number only has 1. I don't really like examples that only have 1, and we come across them every once in a while. But I wanted you to see that difference. Present decimal, start from the Pacific. 1, 2, 3, 4. So that has 4. Present decimal, pass all those magnitude zeros. First non-zero, everything after is significant. This has 5. You don't really even have to go from one side or the other because the 0 is sandwiched between two numbers. So it's got to be a measurement. This is going to have 3 because you're coming from the Pacific side. One nice thing about scientific notation is the coefficient, the numbers in front, are always significant. So those are our numbers and our answers, number of sig figs and answers for 2-6. Now what we need to do is take a look at how mathematical operations affect our number of significant figures, because we'll often be doing mathematical operations and we want to report that final value, and again, we don't want to mislead people. So we're going to start with significant figures, the rule for multiplication and division. Those rules happen to be the same. And what we do is we look at our original values. Look at the original measurements. And our answer has to have, so our final answer after we've done all the multiplication and division, our answer has to have fewer sig figs than the original with the least sig figs. So it's our fewest sig figs that will dictate our final answer there. So look at the numbers you're putting in and make sure your answer picks the smallest. And again, we're going to consider conversion factors. We're about to get into that. We're going to consider conversion factors to be exact numbers. It's not really true. We're kind of lying to you there, but we really have to find some way to start with an assumption that will help you through this. And some are exact, some aren't, and we're just going to work with that assumption here. Now, the rule for addition and subtraction is subtly different, and you're going to wait until you have that opportunity to take AP or IB chemistry in your junior or your senior year. So we're going to ignore that rule for now just to get you used to the concept of thinking through significant figures. So let's go on to our next slide and try some examples. We're going to perform these mathematical operations and we want to round our answer correctly. Now, if you have a series of calculations as we're working up to, right now there's only 2 numbers there, but if we have a series of calculations, don't round until the end, because every time you round, you introduce you're pulling your answer a little bit further away from what should be the true final answer. So try not to round till the end. If you feel like you have to kind of write in between numbers down, carry through like 5 or 6 decimal places or values on those numbers. So try not to round until the very, very end. Now let's look at this value here. We're going to multiply this measurement by that value. Now, if you wanted to just do the mathematics for that, I'm going to crank that out. I'd get 3859.7774. I typically set my calculator to report at least 4 decimal places. And there's going to be a tendency for you to want to just do a calculator dump. Don't give in to that tendency. Instead, let's look at our initial values. This number, we start at the Pacific, 1, 2, 3, 4, 5. This value had 5 sig figs. This value has 4, so our answer can only have 4 significant figures. What that means is we have to round to this place. So that place would be our uncertain at this point. There's 2 ways you can do that. You need to be very careful because the 7's going to round and that's going to cause that to round. But we still need to imply that that 0 is significant. So you either have to put a decimal point there, or you could report this as 3.860 times 10 to the third. And that would make sure that we are reflecting in our answer that there are 4 significant figures. Now let's try the next one. It's a division. We're going to divide 3380 by 4570. So let's go ahead and determine our sig figs. This has 3, this has 4. If you're still not capturing that concept, I really need you to pull me over during class or come to a help session so we can help you process through that. So this can only have 3 because remember we have to go by the fewest. So if I did a calculator dump, I would get 7.39606, and I can only have 3 significant figures, which means I have to round to this place. Again, we have that cascade effect of rounding, but if you point to the place where you need to leave as your final value, I think that will help. So this would be 7.40. Now, scientific notation is not going to help us with this number. On to the next. We have here, in this case, I want to get a little fainter color for us. We're going to be dividing by this measurement. We're going to take this measurement value, but note we're dividing by an exact number. So when we calculate the sig figs, that's not applicable. We're not going to use it. All we're going to use are the significant figures from this value. So we can round our value to 4 significant figures. And I'm going to go ahead because I like to keep my calculator in scientific notation usually anyway. So I would report that as 2.109 times 10 to the minus 4th. And now in that final answer, we have 4 sig figs, we have 3 sig figs. We need 3 sig figs because we go by the fewest. And that answer would be either 7020 after rounding, or I could put 7.02 times 10 to the third. And that really makes it clear that there were 3 measurements and that 0 was actually a magnitude 0. All right, so you want to get used to reporting your values to the correct number of sig figs. With that introduction of measurement, we're going to teach you a mathematical technique called dimensional analysis. So you might want to look forward to the next video, maybe take a little bit of break here and get your brains ready for some fun mathematics.